tonight, if you stand in Wisconsin and look up, you'll see a breathtaking sky with brilliant auroras dancing in the sky. But in just a few days, at that very same location, under that same sky, we'll be unleashing emergency evacuation orders and the heart-wrenching sirens of tornadoes. America isn't facing a single storm, but is locked into a chain of continental-scale hazards. Wildfires raging in the north, massive hailstorms devastating the Central Plains, a supercell tightening around the Oklahoma-Kansas corridor, a square line tearing through suburbs, and a heat dome scorching the East Coast. Auroras don't produce tornadoes. They come from the sun's activity deep in space. But what's about to crash to the ground originates from an invisible force. Rossby waves in the atmosphere have suddenly shifted phase, reorganizing the planet's entire thermal system and putting America on red alert. Have you ever wondered if humanity's defenses are strong enough to withstand a simultaneous attack from both space and the atmosphere? Leave a comment right now. What state are you in? And is the sky above calm, or has it started to get windy? The first sign of an unusual week didn't begin with a tornado funnel hitting the ground, but rather appeared silently on a graphic map. The SPC Hurricane Forecast Center just released its Day 6 Outlook map for Monday, May 18th. A yellow patch labeled Low Risk unexpectedly stretched from Texas through Oklahoma, Kansas, Missouri, Iowa, Illinois, and engulfed almost all of Wisconsin. In operational meteorology, forecasts from Day 4 to Day 8 are traditionally considered taboo territory. The default rule for Day 6 is always a blank map, with no risks depicted. But this map shattered all conventional norms. This continent-sized area of coverage is the first evidence that the atmosphere is accumulating enormous energy. The probability of a Day 6 risk zone appearing is less than 30% of the time, and such a vast risk zone is extremely rare. The SPC is signaling that all supercomputers, from the GFS model to Europe's ECMWF, have reached a unanimous agreement on the scenario of a powerful storm outbreak. This atmospheric machine has formed and has enough energy to sustain itself for several consecutive days. But to understand why this entity is sending such an early warning, we must look higher above the ground, where the Rossby wave is shifting phase. The central figure in this week's series of disasters is entirely invisible. It's not a tornado, a giant hailstorm, or a scorching heat wave. The entity controlling it all is the Rossby wave, giant planetary waves oscillating in the atmosphere. This high-altitude stream never runs straight. It meanders like a great river high above. And this week, that river has shifted phase, reversing its shape. The old configuration of the ridge high-pressure system in the west and the trough low-pressure system in the east has collapsed. An inverted configuration has taken its place, a deep trough in the west and a straight rising high-pressure ridge in the east. This new configuration is the Continental scale destruction machine. The western trough acts as a dynamic pump, sucking dry air from the desert behind it, sharpening the dryline dry boundary, and simultaneously drawing moisture from the Gulf of Mexico northward to trigger superdivision. Conversely, on the other side of the wavelength, the eastern high-pressure system acts like a glass cage, trapping heat and creating the suffocating heat dome at the start of the season. You don't witness separate disasters. It's a single atmospheric pattern unlocking a cascade of hazards. As the dry side of this machine rotates, fires will burn. Yet, before the Rossby machine flipped its course, unleashing hail and tornadoes, it revealed its first cruel side, the dry side. In the northern plains and Great Basin, 17 red flag alerts were active simultaneously, along with 15 densely placed wildfire monitoring orders. Vegetation fuel had dried up 6 weeks ahead of the weather forecast. Single-digit humidity combined with fierce gusts from a western trough created the perfect scenario for widespread wildfire disaster. But raw data revealed the system was creating something far more frightening: dry thunderstorms. The atmosphere was bent into an inverted V-shaped temperature profile. Thunderclouds formed high above, but the air near the ground was too dry. When rain fell, it evaporated completely midway. This process drained heat, turning the air mass into a cold, free-falling weight. It's a dry microburst. A column of air collapses, slams into the ground, and then erupts horizontally like an invisible explosion at 75 miles per hour. Dry lightning strikes continuously, igniting fires in the vegetation. But that's just the dry side. When the wet side opens, the plains officially enter a more dangerous phase. As the dry side finished scorching the vegetation behind it, the wet side of the Rossby system began to activate. A massive pipe of moisture from the Gulf of Mexico was pulled northward, plunging into central and eastern Kansas, bringing Wichita, Manhattan, and Topeka into the sites of violent thunderstorms. The first sign that the atmosphere was transforming into a destructive machine wasn't tornadoes, but massive hailstones. Extreme moisture meeting high daytime temperatures triggered atmospheric instability indices, pushing Cape energy levels higher. Combined with steep wind shear, this quickly transformed ordinary convective masses into the first supercells. Hail over 2 inches is a measure of the strength of the updraft. To keep tons of ice suspended in the troposphere before plummeting at 100 miles per hour, the storm core must have an extremely well-organized structure. This was the knocking at the door of a widespread severe outbreak. However, at this point, the risk of tornadoes is still limited because the low-level jet stream has not yet concentrated strongly. But this is just a temporary lull, a visual illusion before the dry line, the invisible crack in the plains, officially erupts. On a map, it's just a thin, harmless line. But in atmospheric dynamics, the dry line is an invisible continental rift where 2 worlds of air clash violently. To the west, a fiery hot mass of air blows down from the high deserts. To the east, a heavy water-laden, energy-dense stream of air rises from the Gulf of Mexico. When these 2 entities collide over the Great Plains, the dry line doesn't mix them. It acts like a giant hydraulic wedge, forcibly tossing the moist air mass up into the troposphere. The Texas Panhandle, Oklahoma, and Kansas are located right at this critical convergence point. The dry line accumulates moisture to the east, compressing energy into a narrow corridor and triggering storms in the late afternoon when heat radiation peaks. However, empirical meteorology understands that not every dry line creates tornadoes. To unleash destructive violence, it required a delicate confluence of variables: a precisely timed rupture of the atmospheric cover, steep wind shear, and moisture reaching a minimum depth. Without one piece, dry line would be harmless. But by Saturday, the Rossby machine began assembling its final components, pushing planes into explosive action. By Saturday, the trough moved into the Rockies, unleashing a torrent of moisture from the Gulf of Mexico and forcing a sharp dry line. The atmosphere had gathered enough violent components. The dangerous convergence point was now located along the I-35 highway corridor, running from Dallas-Fort Worth through Oklahoma City, Wichita, to Kansas City. This wasn't a lifeless line, but the core axis of America's population and infrastructure. When temperatures peaked around 4 p.m., the cap layer completely shattered, triggering a violent supercell explosion along this atmospheric battle line. Once the storm ignited, it quickly matured into self-rotating structures. The violent updraft continuously churned out massive hailstones, 2 to 4 inches in size, raining down on the ground. Gusts around the edge of the storm's core reached 70 to 90 miles per hour, powerful enough to cripple the power grid infrastructure. For the first time this week, the tornado threat has transformed from a conditional state to a full-blown operational threat. The atmosphere is no longer concealing the violence, but the real climax awaits the following day, when the low-pressure system over Kansas becomes the heart of the entire outbreak. The T Sunday was the moment when the entire atmospheric model accumulated momentum toward a violent peak. Supercomputers simultaneously located a deep surface low-pressure center, 995 millibars deep, towering over Kansas airspace. This entity acted as a mechanical heart, activating a low-level jet windpipe reaching 40 knots, continuously pumping warm, moist air from the Gulf of Mexico up to the plains, increasing the low-level vortex torque. The key to survival lay in the state of discrete supercells. Standing alone, the updraft, without energy competition, could reach heights of 40,000 feet, creating the conditions for the mesocyclone to tighten and generate a powerful tornado. Nature's countdown began. By morning, the ingredients were already in place. By early afternoon, the cap kept the atmosphere suffocatingly silent. By 4:30 p.m., the first storm cells appeared on radar, with the significant tornado parameter soaring to 4 or 6. After sunset, tornado warnings would be issued repeatedly before the supercells merged into a wide squall line. The most terrifying part of Sunday wasn't the dark clouds gathering, but the deathly silence before the storm cap was torn apart. On Monday morning, as damage surveys took off over the plains, many believed the nightmare was over. But this was the atmospheric flip-flop. Monday reload. The low-pressure system didn't weaken, it strengthened overnight. The dryline re-established, the Gulf of Mexico moisture valve reopened, inflating the warm sector and spreading it into the upper Midwest, pushing Minneapolis, Cedar Rapids, and Kansas City into a new risk zone. The fact that almost all of Wisconsin, including Madison and Milwaukee, was covered in tornadoes in mid-May was a major anomaly. The peak of tornado activity there is typically in June, reminiscent of the historic 2011 disaster. Models didn't necessarily predict strong tornadoes would devastate the area, but rather revealed a truth. The warm sector and severe risk had spread so far that it turned previously safe land into a front line. While the Midwest was torn apart by thunderstorms, the East Coast bore the brunt of the same Rossby wave, an amplified high-pressure wave forming the suffocating heat dome. Temperatures soared to 95 degrees Fahrenheit in the Carolinas, 15 degrees above average, turning the Charlotte racetrack event into an early-season heat shock trap. But this week's skies weren't just suffocated by atmospheric pressure. At the same time, Earth's magnetic field was under attack by a G2 geomagnetic storm generated from a coronal hole in the sun. Remember, geomagnetic storms don't cause tornadoes. This coincidence created a cruel contrast. Wisconsin residents were out tonight watching the cosmic aurora borealis, only to face tornado evacuation orders Monday afternoon. Two independent forces, one chaotic week. The most haunting question right now is this the end? Expanding models suggest a harsh reality. This Rossby wave is likely a slow phase shift. The western trough structure may be trapped and persist until the end of May. The Gulf of Mexico moisture valve will continue to pump energy, and the dangerous storm cycle could reload at least once more. Preparation now isn't for panic, but for survival. Turn on your battery-powered NOAA radio, locate shelters, and protect your vehicles from hail. Remember that early summer heat is more devastating than a storm if the power grid fails. The scariest thing isn't an approaching storm, but the fact that the atmosphere has shifted, and America is right under the brink of this new normal.